Scaling Up Nation, Trace Blackmore here with some mind-blowing news that'll make your job a whole lot easier. 3 industry titans, Masters Company, Radical Polymers, and MFG Chemical have joined forces to create your ultimate one-stop shop for your water treatment needs. We're talking over 60 years of Masters Company's expertise in private label products and cutting-edge test kits. Radical Polymers' game-changing Initia additives, and MFG Chemical's custom manufacturing prowess. These American companies are bringing you top-notch quality and reliability all under one umbrella. From blending and ultra-concentrates to specialized polymers and custom solutions, they've got you covered. And with multiple AWT Supplier of the Year awards between them, you know you're getting the best of the best. Ready to revolutionize your water treatment game? Head over to scalinguph2o.com/MFG. Once again, that's scalinguph2o.com/MFG. Trust me, you'll be glad you did. Achieve your goals with the Rising Tide Mastermind. Set your sights on success and let us help you get there. Our mastermind group provides the accountability and support you need to achieve your personal and professional goals. To find out more, go to scalinguph2o.com/mastermind. Once again, that's scalinguph2o.com/mastermind. Find out if the Rising Tide Mastermind is right for you. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. My name is Trace Blackmore. I get the distinct honor of being the host of the Scaling Up H2O podcast. Nation, I just got a huge compliment. I was speaking with somebody the other day, and they called me the Rogan of podcast in the industrial water treatment space. So, hey, he is the top-rated podcast, so I take that as a compliment. And I want to say that we would not have a podcast if it was not for all of you. And of course, you are the Scaling Up Nation. So thank you for listening to these episodes. Thank you for promoting these episodes. We have so many people that will share episodes with people that they know. And a lot of times that's the first time that these people have ever learned about the Scaling Up H2O podcast. So we're getting new listeners all the time. That is because of you. And because of you, I get to do shows like we are doing today. Nation, today is a Pinks and Blues episode. And you know, I love these. I know from the results of how many downloads we get and how many shares we get that you love these. But before we get there, I want to tell you about a few events that are coming up. And so many people will tell me when they see me at one of these events that in most cases, they didn't even know that that particular event was happening until they heard it on this podcast. So, Nation, we have a huge list of all the water events that we know about on our webpage, and that's scalinguph2o.com/events. And we made it so easy where all the events are on there and you can click to go to that event page. You can even click to put it right into your calendar. We tried to make it as easy as possible for you. And each and every week, I try to mention some that I think will interest the bulk of our audience. Unfortunately, we can't mention all of them, but the ones we're going to talk about this week are the National Association of Clean Water Agencies. They are having their 2025 Water Week, April 6th through 12th in Washington, D.C. And this is all from infrastructure funding to utility innovation and all things in between. So if you want to learn more about this conference, please go to scalinguph2o.com and navigate over to our events section. A fan favorite of the Scaling Up Nation is the Water Quality Association's convention and expo taking place in Long Beach, California, April 22nd through 24th. And this is one of the most comprehensive gatherings when it comes to water treatment professionals. It's all about networking. It's all about education, training, business opportunities, all in one convenient location. So we're going to have that information for you on our events page. Another fan favorite is the ASHRAE, which stands for American Society of Heating, Refrigeration, and Air Conditioning Engineers. Their annual conference is taking place in Phoenix, Arizona, June 21st through 25th. And of course, we're going to have more information for you by going to scalinguph2o.com, going over to our events section. And speaking of events, if you were at the Association of Water Technologies technical training last week in Frisco, Texas, I got to see you. So many people came up and said hello to me. Thank you for that. I love it when I hear from Scaling Up Nation members. Got a few show ideas and definitely met a lot of people that enjoy this podcast. So thank you for all the people that I met there. And I absolutely love doing the technical training for AWT. So this was the last one that we do this year, but stay tuned. We'll, of course, let you know when that takes place for the 2 times, because it takes place twice a year, when that takes place next year for 2026. Now, speaking of the AWT, I have met so many amazing people through the Association of Water Technologies. And one of those people is our friend, James McDonald. And here is a brand new What Do You Know?
Hello and welcome to What Do You Know? The game show where we find out what do you know about industrial water treatment, drop by drop. So pump up your brain, take out that test kit of knowledge, and prepare to answer this week's question on What Do You Know? Today's question is, what is a plastic or rubber device that seals the outside of a reverse osmosis membrane against the inside wall of the pressure vessel to prevent feed water from bypassing around the membrane element? It is a brine seal. The design of the brine seal may dictate both its orientation and the direction the membrane should be loaded. I'm James McDonald, and thanks for playing along with us. Stay tuned for next week's episode of What Do You Know?
Well, thank you, James. And I think James McDonald would agree with me that Iron Man is the best Marvel character. Actually, I've never asked him that. I'll have to ask him that next time he is on the show. I will tell you that I am a huge Tony Stark fan. And why not? We have a lot of things in common. We're both entrepreneurs. We both got into our business through our fathers. We are both a red or choleric temperament. Simply put, we are the same person. Well, Scaling Up Nation, I am Iron Man. I wanted to come out and let everybody know on this episode. Actually, they kill him off. So I am not Iron Man. I don't want that to be my fate. And I can't be Iron Man because I don't have the suit. However, and this is true, I did name my car Jarvis. So there you go. There's some useless information about Trace Blackmore. Now, maybe some iron jokes. Maybe you'll like those better. So both FE2 and FE3 go to a carnival. FE3 got denied on one of the rides. Why was this? Because it was a Ferris wheel. There you go, ladies and gentlemen. I'm here all week. Tip your waitress. I once saw a shirt that had a bunch of FE2s arranged around a wheel, and on the very bottom it said Ferris wheel. Well, let's talk about some iron historical figures. So one is Arthur Wellesley, and he was known as the Iron Duke. And of course, that is the Duke of Wellington. We know him as a British military leader, and he was the one that defeated Napoleon at the Battle of Waterloo in 1815. Mao Zedong, the founder of China, was known as the Iron Hand because of his authoritarian leadership style. And we know Margaret Thatcher as the Iron Lady. She, of course, was the British Prime Minister for 3 consecutive terms. And her being called the Iron Lady was meant to encapsulate her reputation and strong leadership. So, Nation, if you haven't guessed it, today we are talking about iron. And this is a Pinks and Blues episode. And we always get our ideas for which Pinks and Blues episodes we're going to do from what you all submit to us. So many of us have either gone to our show ideas page on scalinguph2o.com and just written in what their ideas are, or you've left us a voice message on that same page. And we take all of that information, we curate that into a file, and we get a lot of our future content ideas from that. And that's exactly what we did on this episode. This is how we do most of our Pinks and Blues. And Nation, I will say these are some of my most favorite episodes to do, and they seem to be some of your favorite episodes to listen to. And we know that because of the amount of downloads that these episodes get, as well as the number of shares that these episodes get. Now, they're my favorite because I know they come directly from you. So I know I'm talking about what you want me to talk about, but I'll also say these are my most difficult episodes to do because they do take a tremendous amount of research. Now, I love it when we have a guest on the podcast, but I just have to create an outline and a flow for dialogue on how we're going to take the audience through a journey of introducing the guest, and then interviewing the guests so we can get some of their expert knowledge out of their minds and into yours via the podcast. And the bulk of that work is because of the work that the guest does for that podcast. So those are much easier shows for the host to do. And when the host is just talking the entire episode, I want to make sure that I'm bringing you accurate information. And I know nobody could believe what I'm getting ready to say, but sometimes the information that I know is not as accurate as maybe it should be. So I always like to verify things to make sure I'm telling you the best information whenever I am at this microphone. So all that being said, I love putting these episodes on for all of those reasons, but these are some of the most time-consuming episodes for me to get packaged up and ready to give to you. But here it is. This is a Pinks and Blues episode. And by the way, you might remember in the very beginning, we had a Pinks and Blues segment on each and every episode. And I was just answering questions from you at the time. So it's just 1 or 2 questions. Later, we decided we were going to change the format and we were going to just make an entire episode a Pinks and Blues episode. And that's just how we've been doing it ever since then. So there's some useless scaling up trivia for you. And when I meet people at events, just like last week, people tell me they love it when I talk about statistics and logistics and give them a peek behind the curtain of the Scaling Up H2O podcast. So gave you a little bit more there. In fact, show 400, episode 400, that was our year-end wrap-up. I still can't believe we have more than 400 shows out there. That was where I was all about statistics, all about logistics, all about a peek behind the curtain of the show. And that show did extremely well with downloads, with sharing, and what I heard last week at AWT. So I know the Scaling Up Nation likes things like that. But I also know that you like to learn. So we're going to transition to the subject of our show today, and that is iron. So let's all get pumped on iron. Yes, as a warning, there's going to be weird puns like that throughout the entire show. And we, of course, know that iron is something that we need to live. If we don't have iron, our blood cannot transport the valuable oxygen to our cells. And we need iron to live. We eat iron. It's available in a lot of foods that we eat, like chicken, eggs, fish, all different sorts of meat. A lot of us might take iron supplements. It's a prenatal vitamin ingredient. So people that are pregnant will take iron. So we need iron to live. Iron is something that we all need, but we're not talking about that today. We are talking about the iron that's in our water systems. And it's important to note that our systems are made out of iron. Now, I'm specifically referring to steel. And I will say that one of my favorite How It's Made episodes. Now, you can find this on several streaming services, but I love that show. It's kind of like our job. So when we get a new water treatment account and they're making something there, we have our own private How Is It Made when the customer shows us how they're making whatever it is that they are making. And I've seen so many cool things in their production because of this job. And that is one of many, many, many reasons why I think this is the best job in the world. But specifically, the How It's Made that I'm referring to is a documentary show on how things are made. And one of my favorite ones is how steel is made. So by all means, try to find that. I think you would enjoy that. And you will learn that steel is not naturally occurring. What I mean by that is we can't just go dig up naturally forming steel out of the ground. No, we have to make that. And that's what that show is all about. And they talk about all the things that go into the furnace in order to make steel. And in addition to iron, there's all sorts of other items that go into it. And then a lot of heat is blown into that furnace to get all of those things to come together, also to burn off a lot of the impurities. But there's so much energy that goes into making those things come together when they don't want to come together. And just like you, after a Thanksgiving Day dinner, you would rather use less energy than more energy, and steel has to use a lot of energy to stay in that form. It would much rather use a lot less energy, which is what corrosion is. Corrosion is whatever we're talking about, using less energy, and it does that through corrosion. And now, when we look at what we actually do, we're putting something that wants to corrode the steel into something that wants to corrode it, water, the universal solvent. Folks, if you thought what we do is an easy job, everything is working against us. So there you go. We are definitely superheroes just through trying to inhibit corrosion alone. So let's talk about the different types of iron. And I refer to this as the iron triangle. Now, Fe is elemental steel. This is what the steel manufacturers are using to make steel out of. And again, all those things that they add into that furnace, it's all to try to get it as much in that elemental state as they can. A fun fact, steel is probably the most recycled material on this planet. So old steel products go into making new steel. So be sure whenever you recycle some old things with steel in it, that is going back to make new steel. Now, so we have elemental iron, so it's Fe, if you will. And then we have what's called ferrous iron. Of course, you heard me make a joke about that earlier. Now, this is typically the iron that's in our systems. It's the soluble form of iron. This is found in our water systems. Now, there's also ferric iron, which is Fe3, and this is a more oxidized state of iron. And if you see red, rusty water, this is iron in its ferric state. Now, in our water systems, typically we're worried about total iron, and total iron is ferrous iron and ferric iron, including any insoluble form. So anything that test can test for, that's what's going to be in total iron. And we, of course, do this with using one of our tests. And I think the most common test used is the phenanthrene method. And this is typically mixed with an agent so we can get total iron, which is just what I mentioned earlier. That's when we have the Fe2, the Fe3, as well as any other insoluble forms that can react with. Now, I believe Hawk calls there the Ferriver reagent, and that already has the agent to convert everything to what we need to test for it already mixed in with the phenanthrene, and we just run the procedure there. They've made it nice and easy for us, and we read it off of either our color wheel or maybe we have a spectrophotometer. And that gives us a reddish color that we read. Now, the proper way to read this, I think, is not with the eyeball. And a lot of people will use the eyeball. I really like using a meter for this. But in a lot of cases, a system will be out of range because there's too much iron in that system. So now we have to dilute the sample so we can test for it within whatever the range of the meter is. Now, the proper way to do this is to rerun the entire sample with the correct amount of DI water and the correct amount of sample. And then once you get your reading, multiply whatever that dilution was. That's the proper way to do that. That's the best answer way to do that. And in a perfect world, that's how we would do that every time. But I know that a lot of times when we're testing iron for a cooling system, we need to know generally what that result is. And if it's off just a little bit, it's not really going to affect what our recommendations are going to be. So here's what I do. I will measure off, say it's a 10 mil sample, I'll measure off 5 mils and dilute that with another 5 mils of DI water, and then I will test that. I believe that the method I'm referring to, which is the Ferriver method that Hawk has, you can do that within 1 minute of the test being ready. And anything after a minute, it actually starts darkening. So anyway, doing that, you're then able to read the sample. And then remember, you just diluted it in half. So whatever you get on that meter, you're going to have to multiply it by 2. If you did a different dilution, whatever that multiplier is, that's what you would do on whatever the meter is reading. And now you've got a result and you can make a recommendation on that. Now, there are some people out there that are listening, I have no doubt, that are saying, Trace, I need to be more exact than that. Okay, that's fine. If you got all the things you need to do this in the field, awesome. If you don't, I would grab a sample, and then in your lab, I would actually measure out in grams what you need to get a proper dilution, and then go ahead and run your test there. That's the best way to do that. You're going to be exact. Again, depending on what you're testing for, I think that's way overkill on probably 99% of the systems that most of us are responsible for testing. But as I mentioned in episode 399, and that was the one where we talked about doing serial dilutions, most of us don't carry fancy lab equipment like lab scales in our test kit. We keep those back in the lab where they're safe, where they're well lit, where they're not going to get damaged, where they're balanced, all of that stuff. By the way, that was something that came in from episode 399. People said, hey, one of the reasons you don't carry a scale like that into the field with you is you got to balance it. Well, you probably could balance it on a drum because it's got a little level that's on it, but you typically don't take a several $1,000 scale into the field with you. At least I don't. I don't trust myself. Maybe your company has some different policies. Anyway, I am totally getting off the topic here. So that's how I would dilute a sample, just very easily. But also realize that if we're using the phenanthrene method, that there are some common inhibitors that we use that do interfere with this. And typically that is molybdates and nitrites. So go ahead and look into your test procedures to see what the interferences most commonly are in the test that you are using. And most of your procedures, there's probably a workaround for that. 9 times out of 10, it is a dilution. And sometimes the limit is just so high, it doesn't matter. That's why I say you got to read your procedures. And an episode you might want to listen to when we talk about more things like that is episode 397. And that was all about how I look at the tests in my test kit. So feel free to check that out after you're finished listening to this episode. All right, Scaling Up Nation, it's time for a word from one of our sponsors. Today, I want to talk to you about a hidden threat lurking in your cooling water systems, biofilm. You know that slimy stuff that causes all sorts of headaches for us water treaters? But don't worry, because I've got some great news for you. Our friends at AMSA have developed products that are absolute powerhouses when it comes to biofilm control. These aren't your typical products used in biofilm control programs. Oh no, they're much more than that. AMSA's products actually penetrate and break up those stubborn, gluey deposits. This means your biocides can work more effectively and at lower levels too. Plus, it weakens the biofilm matrix, allowing it to be washed away with the flow of water. By incorporating AMSA products into your biofilm control program, you can say goodbye to your concerns about microbiologically influenced corrosion, scale formation, reduced cooling efficiency, and even minimize the risk of Legionella in your systems. So if you want to clean it up and keep it clean, head over to scalinguph2o.com/AMSA to learn more about their innovative biofilm control solutions. Once again, that's scalinguph2o.com/AMSA. Trust me, your cooling water systems will thank you. Let's jump back in right where we left off. Now, in addition to some of the things I learn when I get to talk to the fine members of the Scaling Up Nation, and they like the statistics and the back curtain view of what's going on with the podcast, I find that people love it when I teach them math on the podcast. I got to tell you, that's a little weird to me, but it's my kind of weird. I love math. So you are definitely my kind of people. So we're going to do some math here. I love using math in sales because you're using math and you can actually normally show somebody an ROI on what they are doing. Not sure how much of an ROI you can get with this, but it does allow you to get a visual of what's going on in your system. So let's go ahead and calculate how much iron in pounds is in the system. Now, typically, I convert things to 1,000 gallons of water. The reason I do that is that's where the equation of parts per million is derived from, 1,000 gallons of water. If you remember from a previous show, actually several shows that I did, I explained that a pound of anything in 1,000 gallons of water will yield 120 parts per million of whatever that pound was, of anything. So knowing that, we're able to factor out and do equations like what we're doing here. So we're going to calculate the weight of 1,000 gallons of water, and we know that water weighs 8.345 pounds per gallon. So 1,000 gallons of water weighs 8,345 pounds. And to find the weight of 1 part per million in 1,000 gallons of water, we'll say that 8,345 pounds divided by a million, because it's parts per million, gives us 0.008345 pounds. So that's what the weight of 1 part per million in 1,000 gallons of water is. So then you just simply take the number of parts per million that you recorded in your iron test, and you are going to multiply that by 0.00008345, and that will equal however many pounds you have in your system. Now, that's not going to be a huge number unless you just have a tremendous amount of iron in your system, but it does allow you to show the customer that that's not water. And imagine that stuff now in your system creating all the havoc that it does. And that gives people a reason to want to sign off on the cleaning that you recommended. Or maybe you've got a filter feeder that you want to install or some other sort of filter system. This kind of allows you a better way to have a conversation around that. Now, the other reason that they really want to get that iron out of the system is iron is a dissimilar metal to a lot of the other metals that are in your system. And let's face it, the corrosion inhibitors that we put in our system are lazy. They want to go to the easy stuff first. So if we're putting corrosion inhibitor in to protect the system from further corroding, if there's easier stuff to get to that's floating around the system, and I use that term floating in jest, but I think it's a good way to look at it, it's going to go to that first. And now we're going to have to put more product in because our product's getting used up on stuff that we really don't want to protect. We want to get it out of the system. So with all of that and letting your customer know what we are trying to do, that might allow you to sell that filter feeder. It might allow you to sell that cleaning. I've seen a lot of people now in glycol systems, they will hook up a filter and some resin on it to try to take the iron out of the system so they don't have to waste the glycol. There's so many things that people are doing. And now you've got one other tool to help you do that. Iron is one of those tests that you need to test, I believe, on all of your systems. I spoke on episode 397 that I look at iron, if there's anything that's not coming in on the makeup water, that is normally an indication of excess corrosion that's going on in your system. And you can kind of figure out, okay, well, how do I fix this? And typically the first step is we need to get it out of the system for the reasons that I just said, that chemical is lazy. And then once we have a clean system, it's a lot easier to not only keep it clean, but to keep it protected. Now, whenever we talk about corrosion, I want to add that we are never going to stop corrosion. It is impossible. We're putting something that wants to corrode into something that wants to corrode it. It's a hard job. It is an impossible job, but we are also making it so it is corroding so much less because of the fine work that we are doing that system is going to live a lot longer. But it's important to know that you are never going to fully arrest corrosion unless you paint the interior of the system, but typically that doesn't work well with heat transfer systems. I actually remember a customer doing that one time, and I think it worked great to solve for corrosion issues, but they had no heat transfer, so they rendered their system utterly useless. So don't do that. Take it from that customer's mistake, and they had to replace that system because of that. I guess it was a good try. Didn't work. Don't do that. Why does that work? Well, in corrosion, there are 4 things that you need. You need an anode, a cathode. You need them to be connected somehow in an electrical path, and that we just described a pipe right there. And then you need an electrolyte. Well, that's the universal solvent. That's the water. Folks, a corrosion cell is what our system is, and we're trying to put products in there to slow that down as much as we can. And I can do a full show on corrosion. I could probably do a full series on corrosion, but for now, we're just going to keep it towards iron. And I hope you learned some things about iron today. I hope maybe this inspired you to look at another one of your tests, discover what the method is, how it works, what are some of the interferences with that method, how would you compensate for that in the field, why are you testing for it in the first place? And then if it's out of range, what are you going to do to get it back into range? What are your actual solutions one way or another? So when you encounter this, you now know what to do. I encourage you to do that with each one of your tests. That's how you're really going to learn your test. That is how you are going to become proficient in your tests. And I'm going to say one more time, and I said this several times on episode 397, if you're having to look at your procedures when you're running your normal battery of tests, you just don't know your test well enough. And it's not just memorizing the procedure, it's understanding all the things that I just mentioned. And if you are just feeling like you're burned out, you're going through the motions, and I just described how you run tests by reading the procedures, well, no wonder you're doing a task. Folks, there is so much magic in this industry when you can change a task to something that you understand, because now your mind becomes a participant as you're collecting the sample, as you're preparing the sample, as you're running the sample, as you're reading the sample, because you have a hypothesis of what's going on and what you're going to do about it. And now that test isn't a task. That test is a way for you to prove or disprove your hypothesis. And that's just energizing to me. That's not boring at all. That's not checking the box that I did something. That is an active tool in what I am trying to do. And that's what makes it interesting. So if there are any parts of your job that you're just treating as a task, I am going to say you're doing your job wrong. This is such a fun job. I told you in the earlier part of the episode that it's our own private how's it made. Ask a customer a question about the wares that they create in their facility, and normally they will just glowingly talk all about the things that they do, how they do it, take you on a tour. And not only are you getting more comfortable and closer with that customer, you are also learning more about the system that you are charged with protecting. And again, it makes it fun. It's our own private how is it made. I don't think that show is back on the air, but I do know that it is streaming on several services. And if you punch in YouTube, in fact, we will have a link from where the steel episode is on YouTube. So we'll make that really easy. Just go to our show notes page. Hey, while you're on our show notes page, is there another idea you have for a show? Is it something about another test? Is it something about something your customer asked you and you can't find the answer to? Or maybe you found the answer and you think other people need to know about that? Well, don't keep things like that to yourself. Make sure you go to scalinguph2o.com, go over to our show ideas page, and be sure to leave that information with us. Because of people that did that, we were able to answer about a half dozen questions on questions around iron today. And people seem to enjoy when I just take a bunch of questions and roll them all up in a show. So make sure we've got plenty of content as we are planning. Get your ideas to us. That is so appreciated. So, folks, iron might be essential for our bodies, but it can be a real troublemaker when it's dissolved in the water in our systems. So don't let iron catch you off guard. Be proactive, be vigilant, and most importantly, be the iron fist that keeps your water flowing clean and clear. Until next time, Scaling Up Nation, remember to scale up on knowledge so you don't scale up your systems and you don't rust up your systems. Stay ferrous, my friends. We'll catch you next week with a brand new episode of Scaling Up H2O. Are you ready to take your water treatment career to the next level? Get the confidence you need to sign up for the Certified Water Technologist exam today by taking our Certified Water Technologist prep course. Learn valuable tools and techniques to help you succeed. Plus, test your knowledge with our 100-question practice exam. Visit scalinguph2o.com/CWT prep and put yourself on the fast track to certification. Don't wait, start today.